Good day, everyone, and welcome to this session on robotics and how to develop and operate robots using the cloud. My name is Franz Steinberger. I'm the head of technology for energy at Amazon Web Services, and I'm based in Houston. So when I was preparing this talk, I was thinking about what's actually the definition of a robot. And to my big surprise, there are many definitions of what a robot is, and I sort of like the one shown here on the screen. A robot is an autonomous machine capable of sensing its environment, carrying out computations to make decisions, and performing actions in the real world. So this is a very nice definition, but it still leaves a lot of room for interpretation. And later on, we will see many different incarnations of what a robot can be and what a robot can actually do. Robots are not really new. They've been used for a while in the industry. Initially, they started off with being very simple, basically performing repetitive tasks that are very boring and difficult to do for a long time for humans. Think of welding robots that weld together pieces of metal, for instance, positioned along an assembly line for building cars. But even these robots have become more and more complex over the years. And with the increased functionality and capability of robots, they are also now found use in many other industries, from healthcare to construction, from warehouse logistics to oil and gas. And the use of robots is poised to increase quite a lot over the coming years, going together with increased capabilities and technologies available, especially from cloud providers. Building a robot is actually not that straightforward. There's a lot of challenges that they have to overcome before a robot really is useful and functional. First of all, as I mentioned before, robots are no longer simple robotic arms that do one task and one task only. They combine now a multitude of capabilities, and there's a lot of expertise from different domains that is needed by developers and engineers to actually build these robots. That includes machine vision and artificial intelligence. Also, early on, robots were really one-off purpose-built machines with software purpose-built for this machine and for a particular task. With the increased functionality of robots, the software, basically the robotic operating system, also has become more complex and follows now also a more modern software development path. So no longer is a software for a robot developed as a hard-coded thing. It's developed with modern software development methodologies, for instance, continuous integration, continuous development, where new capabilities and functionality is added on a continuous basis rather than build something and have a release once or twice a year. Also, we're no longer talking about a single robot that you probably know by name. We're talking about lots of robots, fleets of robots. So managing them, configuring them, deploying updates becomes a real issue and needs a completely different approach than in the early days. Finally, testing of robots, robotic hardware, and how robots behave is not that straightforward, right? And requires a lot of thinking, a lot of planning. And it's also at the same time very important that you test out the capabilities and behavior of a robot before it is actually deployed in the real world. And that brings me to something that's going now hand in hand with robotics development. It's using simulations. Simulation in this context means we are building a virtual world and let the robot roam around in this virtual world, and we can monitor and test the functionality and behavior of this robot. So this is not only a lot cheaper to do than actually carrying a robot to a site and see what it does. It can also create many more scenarios, as many as you want, and it can also create scenarios that are very difficult to find in the real world, so-called edge scenarios, and test them basically in a computer model. So that really enhances the software development cycle. Results you can get very much quicker and also reduces the cost by using these simulated worlds. Here you see some examples of simulated worlds. On the right side, you see a little room with some shelves and robots moving around. So you can very easily test them whether they run into some objects or if they sense them and can get around them. On the left upper side, you see a virtual world with true sense. That's probably Moon or Mars, and some rover moving around, and you can test out the different terrains and whether it can go around boulders, what it does on slopes and things like that. And of course, that's very, very useful because it's not straightforward to test things on a different planet. And on the lower left side, you see some sort of a hospital environment with a reception area. And that's actually quite an interesting use case because you see a robot here. And mapping out the environment, the geometry of the room and where furniture is, that's not too difficult, right? You can run a mapping run and then the robot knows where things are and can navigate around it. But look at the other things that are in this room. There's a chair and there's people. And they are never in the same place. So when the robot comes back, these things will be in different places. So beside the mapping capability, knowing where things are in a static way, the robot also needs to have real-time sensing capabilities and include this in his skills so he can operate really in an environment where things are changing. And all this is very easy to test and simulate in these virtual worlds. So let's go to some industry use cases now, right? I'm going to look at use of robots at home, warehouse logistics, and then some really impressive use cases for oil and gas. Many of us probably already have some cleaning robots at home. In this case, I'm showing a study or an example of iRobot. Over the years, they have now sold millions of robots. Of course, all these robots have sensors, they have mobility, they have certain other capabilities, and they have software installed on these vacuum and mop robots. And software development was getting increasingly complex with the number of robots deployed and the increasing complexity of these robots. So iRobot was really looking at scaling this development environment, and they started using AWS RoboMaker, which is basically a robotic operating system available as a fully managed service in the cloud, and it includes also capability to have simulation environments and to have tools to build virtual worlds. So by moving to a cloud-based robotic operating system, not only could they speed up the software development cycle itself using modern ways of doing software development using a fully built out CI/CD pipeline, they also now could build many scenarios, virtual worlds, and use them as part of the regression testing before a software release. So it can test now hundreds of scenarios before any of the software updates go out, and can be very sure that the robots still behave as expected after the update. Here's one of these virtual worlds. You can see basically a room in a family home, some furniture, some walls on the left side. And on the right side, you see basically the path the robot takes trying to clean this area. And you can see it's very straightforward in a virtual world to see where it is going, where it is not going, areas where it has problems to get around or is not cleaning properly. And then you can very straightforward apply updates to the software, change the algorithms, fix the algorithms to improve the behavior. Or that very straightforward in a virtual world. Next, let's look at Amazon. Amazon, as you know, operates a lot of warehouses, so-called fulfillment centers. And Amazon uses a lot of robots to automate the movement of items that we purchase from the shelves where they are stored to the area where they are packaged by workers for shipment and delivery to the buyers. Robots are used at large scale in the warehouses. You see them here moving around shelves. There's a whole fleet of robots. Amazon acquired actually the initial warehouse robots from Kiva Systems in 2012 and has since then continuously improved and optimized these robots So they are now highly autonomous and they operate as a large fleet of 10,000s of robots. The initial business case was very appealing. Workers used to walk 15 kilometers or more per day, going to shelves, picking up items, bringing them to the packaging area, and then do this all over again. Now, using robots bring the items to the workers, and the workers stay in one place packaging the items. So it's a huge cost savings and also much nicer working environment for the workers themselves. Of course, in the real world, something can go wrong. And for instance, sometimes items fall off the shelf and they need to be picked up by a human being. So in this case, if you look at the sequence of images on the left side, there's Adam, so-called robotics responser, whose task is to find and pick up these items that were lost. And in order to go into the area which is normally reserved for robots, Amazon developed a special vest that he is wearing. When an item is dropped, on the lower left side, you see now a flashing light that informs the worker there's something wrong. On a tablet, you can see then a path to this item, to this dropped item, through the corridors of shelves. And while he's walking, the vest emits a pulse that tells the robots there's now a human being in the area. So the robots then sense this and they stop moving around, and they stop basically running into the human being. And once the human is passed by, right, then the robots continue moving around. So then, of course, they can pick up the items, put them back into circulation, and the whole operation is back to normal. So this is an example of interaction between humans and robots, which I think is quite interesting. Now let's look at some use cases for oil and gas. The robots have been used for quite a while in oil and gas, and the usage or demand for using remote and autonomous devices and robots has actually increased over the last year and a half during the pandemic, because many certified engineers and inspectors simply couldn't go to sites and do their work on site because of the pandemic. So use cases for robots in oil and gas include inspection robots for pipes. Think of the lots of pipes and winding pipes in refineries and petrochemical plants that need to inspect it for cracks or dents, or maybe reduced wall thickness of the pipes because of corrosion. So that's done using mobile robots, almost crawlers that go along these pipes. There's also an interesting device, so-called ocean surface vehicles, basically little robots, if you want, that float on the surface and can take continuous measurements or mappings of the seabed, and can also record seismics, for instance, deep earthquakes, while floating on the surface. Robotic refueling arms are quite popular, especially in large industrial plants or construction sites, that then refuel automatically heavy equipment or trucks. And of course, there's a large group of remotely operated vehicles or fully autonomous vehicles that are used in subsea environments to inspect pipelines or other subsea installations. If you look on the left side, this is an example of a drilling platform, an offshore platform, rendered in RoboMaker using this simulated virtual world. And if you look very carefully now on the left side, you see a little drone moving around the platform. So this is a real use case where drones are used for inspecting offshore platforms and to see whether there is any issues with rust. And the path of this drone is simulated first in the virtual world and optimized, and then it's deployed in the real world. And once the rust has been mapped, autonomous crawlers are used to go and treat the rust using sandblasting and then applying inhibition materials. So this is not only a technically impressive use case, it also saves up to 90% of costs compared to using humans. And there's even more important aspect to this. If humans had to do this inspection, they would be hanging off ropes of the offshore platform to try to do the inspection and the remediation of the rust. And that's a huge health and safety risk, which can be avoided by using these autonomous vehicles. Now let's talk about a very impressive use case where a lot of different technologies are combined to solve a real industrial scenario. This is from Woodside, an oil company from Western Australia. Woodside operates onshore and offshore facilities in northwest Australia, a really remote area. So early on, they have been very keen on using a lot of instrumentation, remote sensing, and real-time remote monitoring to automate the operation of the facility. What they have also done is they actually create a true digital twin of this LNG plant. And LNG stands for liquefied natural gas plant. Basically, this is a facility which takes the gas which is produced offshore, liquefies it, and then puts it on ships and sends it to consumers in, for instance, Japan, because there's really not many consumers for gas in its gaseous form in Northwest Australia, right? And so they basically used CAD drawings and LiDAR scanners to create this 100% correct representation of the LNG plant. There's billions of data points that are being rendered. There's hundreds of thousands of IoT sensors that are streaming data in real time to the AWS cloud. And that's where they are running our advanced analytics and machine learning models, hundreds of these models on a daily basis to perform operational tasks. What they also realized is there's areas in this plant where there's no instrumentation, or where normally human beings and operators go to take certain measurements, read gauges, or do some other visual inspection. And some of these areas are not very nice. It's very hot, sometimes up to 50 degrees Celsius. Some areas can be hazardous for human beings, right? So they started using robots to perform these tasks. And they use now the digital twin to map out the paths the robot should take to get to these areas in this virtual world to see, can it go around the corner, can it go around the staircase to get to this area. So I would highly encourage you to watch this YouTube video, which shows the whole project from building the digital twin to robotics and all the machine learning use cases. I just extracted one small part from this video where the presenter talks about how they use robots inside the digital twin.
No talk would be complete without our little robotic friends. So this is a little ClearPath Scout robot that we have on site. And of course it transmits its XYZ, yaw, pitch, roll. And so we can incorporate that into the virtual environment and see where they are in real time. And then we can also use this to actually summon the robots to our current presence. Or my particular favorite idea that the team has is, I want this robot to be in front of this piece of equipment at 9 o'clock tomorrow morning, so I can actually have real-time thermal scans, ultrasonic scans, pan, tilt, zoom, whatever it is you want, gas sensors, whatever it is you want, we can mount on there.
Woodside also uses more advanced robots. Here's Ripley. It's a mobile robot with a very advanced robotic arm. And they plan to use this robot, or actually using this robot already, on unmanned offshore platforms to do simple tasks or simple repairs. And one of these scenarios is simulated on the right-hand side, where you can think of an anomaly that happened in this facility, and the robotic arm is simply pushing a button, turning a few valves to rectify this anomaly, right? You would say that's something a human being could do a lot faster. But remember, this is an unmanned offshore platform. It takes probably 2 hours by helicopter to get there. And it's usually 3 to 4 people that are on this helicopter, pilot, inspector, supervisor. Then they go there, turn a few valves and push a few buttons, and then they fly back. So it's very advantageous to have this robot stationed out on this platform and using a lot of autonomy and advanced capabilities to perform these tasks. So Woodside used the AWS RoboMaker environment to develop the software for this robot to basically develop capabilities to analyze the data that comes from the sensors, doing the management of the robot, and also, of course, test the whole robot in a virtual world before it was deployed. And because it was done in the cloud environment and the AWS RoboMaker environment, which provides the robotic operating system, is extensible via APIs, they could also take advantage of other technologies that are available as simply services in the cloud. For instance, just with a few mouse clicks, they could enable video streaming from the robot to a control room. They could enable sensor readings in real time, could add speech to this robot just a few mouse clicks away. So this brings me also to the last slide, and I thought I will talk about where things are headed. And one of the biggest challenges for robots these days still is dexterity, or better dexterity. How can we make a robotic arm to do more complex things? Things that are very straightforward and simple for a human hand are still very, very difficult to perform by a robotic arm. You see on the other left-hand picture, a robotic arm trying to pick up a book with a strap, right? Very, very difficult to achieve. Of course, Amazon is also looking at autonomous vehicles for delivering packages to your doorstep. So you could see potentially one of these little devices moving around in the neighborhood. Maybe even think of this device gets stuck or gets lost, maybe it can communicate with a bystander and ask for help. All the way down to actually humanoid robots. Here's an example of Robonaut 2, which was developed by NASA and is deployed in the space station. Actually, Woodside has one of these robots and are destined for deployment on these remote platforms. And these are really advanced robots having a lot of capabilities in the robotic arm. They're also very mobile. And I think it's very exciting to see how far we have already come, but there's still a lot more work that needs to be done. But what this also shows is that it's way more complicated to develop these robots now. And there's a lot of technologies that need to be integrated that may not be that straightforward to use for traditional robotics developers, right? Like image recognition, streaming IoT data, machine learning, artificial intelligence. That's why it is very important that now there's robotic operating systems that are available as a managed service in the cloud. So it takes away all these mundane tasks to build the software for a robot. And at the same time, because this operating system is extensible, you can simply tap into advanced technology available in the cloud and make the robot then to navigate around, communicate, stream data, and learn just with a few mouse clicks. That frees up a lot of time and also saves a lot of money for the engineers to actually focus on developing really unique and differentiating capabilities, because all the basic framework, the basic operational side of things is taken care of by a cloud-based robotic operating system. Also, because of the extensibility, this should open up the development of a really healthy ecosystem of startup companies that build unique capabilities for robots, maybe just plug them into existing frameworks, and that should altogether accelerate the innovation in the area of robotics. Finally, I want to touch on something that's often forgotten. As robots become more complex and also start to operate in environments where humans, we have to make sure these robots really perform 100% like they are intended to do. And for that, we need to introduce some regulations and certifications to make sure this is actually happening, right? And there's already ISO certifications for robots that take care of this problem, right? And I think regulations and certifications for deployments of robots will just become more and more important in the future as robots become more commonplace and also become more like a co-worker for humans. So this is also bringing me to the end of my talk. I hope you enjoyed this presentation. Hope I could show you some interesting use cases from different industries. Also hope you saw that developing robots and the software for robots is not that straightforward, but cloud can really help you in accelerating the deployment, the operation of robots, and also the addition of advanced technologies. If you have any questions, please feel free to reach out to me. Otherwise, have a good day.